Welcome to Enhanced Practice, a monthly Google Hangout on air that dives into the fundamentals of parametric design with the conceptual design and analysis environment Vasari, using Dynamo, a visual programming add-in for BIM. This live stream will broadcast on the third Friday of the month at 12 p.m. My name is Ronnie Parsons. I'm the co-founder and director of learning innovation at ModeLab. We're a multidisciplinary design and technology consulting firm located in Long Island City, New York. And this live stream is in partnership with Autodesk. So today we'll be looking at some quick and easy ways to create and edit data sequences in Dynamo. We have a few short examples to go over, so let's go ahead and jump into Dynamo. One note. Please remember that each session will be recorded and posted to our YouTube channel immediately following the live stream. And please post questions to the Q&A in Viewer app. Demo files will also be posted after the demo is complete. Now, one note, we will be using Autodesk Vasari for the demos today. So if you haven't already downloaded that, go ahead and browse to the AutodeskVasari.com link. That'll be included in the Google Hangout. And you can also get there by browsing to the link indicated right here in my presentation deck. So we'll also be using Dynamo for the presentation today and for the demo files. So if you haven't already downloaded Dynamo, go ahead and you can do so by browsing to dynamobim.org and following the download link in the top right menu. The direct link is also going to be posted to the Google event, so keep an eye on the feed there. So for the demo today, we are going to be using Autodesk Vasari Beta 3.0, as I was mentioning before. And whenever we're launching Dynamo, if you haven't already had the experience of working with Dynamo, you'll note that you do have to launch the project or family environment depending upon the kind of work you plan on doing with Dynamo. So today, because we're going to be using just kind of Dynamo within Dynamo, we're not really going to be attaching it to Vasari in any way. We will be just launching a new project to get started. So I'll do that by going to the project browser here, and I will use the new button to be able to launch. So I'll just click here. Alternatively, you can always do that from the toolbar at the top left. You can also do that from here in the Vasari drop down. So either way, whatever you prefer. Now with Vasari open, we're going to need to. All right, 1 second. Seems like perhaps my screen capture the right interface. So let me just go ahead and bounce back so we can make sure everybody sees us. From here in the project browser, you'll see that you have the option to create a new file by just clicking here on the Create Vasari Project File button. And with Vasari launched, you're going to want to go ahead and go up to the top, browse through the tabs to Add-ins, and click on Dynamo 0.7 alpha. Now, one note, you'll notice that I have both the 0.63 and the 0.7 build installed. And so if you want to launch in the previous Dynamo build, you can do so by clicking here in the Dynamo version button. And that will require you to restart Vasari. But since I already have 0.7 loaded, indicated here by it saying 0.7 alpha, I can go ahead and just launch this. It's a way of being able to work with the daily build as well as a previous build and not have conflicts. So I'm just going to click on that button and launch it, and we'll see that Dynamo is now floating in front of Vasari. I'll just go ahead and maximize the window so that we have a maximized viewport. You know, just a quick refresher, the space here, the canvas is also here in Dynamo referred to as a workspace. This is where we'll be doing the work, you know, creating the definitions today. Over here on the left, we have a node library where it's organized based on a series of drop-down categories and subcategories. So we'll be bouncing in through here and taking a look at the various nodes that we can use to kind of work with data in the new pre-release of version 0.7. Now, at the top of Dynamo, you also see that there's a series of menu drop-downs. The most important one that we'll look at today, is View, because that's going to allow us to turn the background 3D preview on and off in our workspace. And it'll also allow us to basically change the connector types if we want to look at the different types of connectors that Dynamo allows you to use. I'm going to bounce over here again because it looks like, all right, it looks like Google Hangouts is not being my friend today. So just a refresher again, this is the workspace right here at the center of the screen. On the left, we have the node library. You can open and close the various levels of the library by clicking these drop-downs. Here we have the quick access toolbar for creating a new file, opening a file, and saving. Here at the top in the menus, we have File, Edit, View, and then from View, we'll turn on the background 3D preview to be able to see what's kind of being solved in our definition as we build. So I'll just turn that back off by going to View, Background 3D Preview, and turn that back off. So, today what we're going to do, since this is the third session where we're diving into Dynamo, is take a look at the ways in which we can begin to use the number sequence objects as well as the number node objects to be able to effectively work with data and construct data on the fly. Now, one note is that we'll also be looking at a new feature which is called a code block, which will extend some of these data management techniques to allow us to more effectively, efficiently, and kind of quickly iterate on an idea by essentially basically internalizing some of the Dynamo features or nodes into one object. So, to get started, let's do something really simple. Let's search for the number sequence. Now I'm going to look for the number sequence from here under the search field just by typing in number SEQ, and you'll see that the top hit right here is the core list create number sequence. Now, with this node, you'll notice that we have 3 input ports here on the left, and we have an output port on the right. One of the first things I do is I'll just drop in a watch node. So I watch, hit enter, add it to the workspace, and go ahead and connect output of the number sequence. Now, when you hit run, located down here at the bottom left corner of the window, we're going to get an orange warning here because we have 3 inputs which are not defined yet. However, we do have the output going into the watch. You'll see that the watch is saying null, or hey, I don't have what I need to be able to actually show you anything. So to define the start, the count, and the step amount for a number sequence, I'll go ahead and just drop in a node. And with the number node, I'll go ahead and say that I'll start at 0. I would like to have 10 values. And we'll go ahead and just step by an increment of 1. So this number node is, a nice object because you can kind of quickly define values. I can select the 3 number nodes and then right-click on the workspace and say X average, which will allow me to align these nodes. And I'll go ahead and hit run once again. We'll see that we now have a sequence of values. This is a number sequence, right? So it's starting at the start value. It is iterating for the X number times specified in amount, and it's stepping by a value of whatever that increment is. So if I say 2, for instance, hit run again, we'll see that we still have the same number of values, but now we're incrementing by 2. I'll go back to 1. I'll also go ahead, right next to the run button, I'm going to go ahead and click on run automatically. And now if I hit run, and I make any changes, well, as soon as I hit enter, this is going to update dynamically. And that's really what I'm looking for in this visual programming environment, is to get a little bit more interaction out of the various kind of inputs that I'm using. Now, when we take a look at this number sequence and the way that it's been defined, we'll see that we're using, again, a start value, count value, and then an increment value. And an interesting thing about the number node is that it's a little bit more flexible than what you might first understand. The flexibility in it is that you're able to define strings. So if I were to say 0 and I use dot dot, I'm going to use pound 10 dot dot and 1. We can compare the output of this using a watch node and see that we are able to achieve the same number sequence as we did with the number sequence node. Now, a couple things that are kind of nice to tidy up the viewport here. I can always collapse the library, and I can use the icon here in the top right corner of Dynamo to be able to zoom to extent. So this is some kind of basic UI stuff to be able to kind of zoom in and out and just make it a little bit easier to see what you're working with. So again, here you'll see that the kind of string that I'm using, if I go ahead and add a comment node, just do that by hitting Control W, is start, and you want to use pound count dot dot and increment. Right, now there are a number of other strings that you can use to be able to play with the number node for creating sequences. So let's just take a look at just one more. So I'll copy and paste again. And this time what I'm going to do is I'm going to say 0 to 1, and I'll say pound 10. Let's just compare the difference. So here, if you notice, I'm starting at 0, but I'm ending at 1. And I'm doing this for 10 steps, essentially. So the pound here is identifying really the kind of quantity or count value, and the 0 and 1 position are defining the start and end. You can think of this perhaps as something similar to a range object in Grasshopper, and then this would be a little bit more like a kind of series object in Grasshopper. Now, provide you with a file that will have kind of all the various strings that you can use in these node objects to create sequences, but for the sake of time, I'm just going to use these two to start. Now that I have a kind of sequence defined, I'm not going to really keep this collection in the workspace anymore. I'll just delete that. And what I'd like to be able to do is use this number sequence to define a collection of points. Now, I'm okay with just using the series, so I'm just going to delete these other two nodes and work with this sequence of values here. Now I'm going to expand my library once again. Since I'm going to try to create a kind of collection of points, I'm going to just use the search field once again, point. And in doing so, we'll see that top hit again, geometry, point create by coordinates. And since I have this set to run automatically, I can take the output of my number node and connect it to the input ports. So we'll say X and Y, and turn on the background preview of the workspace. So I'll just go ahead and turn that on. To navigate the background, you can use Control G, and you'll see that the middle mouse down will pan, the right mouse down will orbit, and you can zoom with your middle mouse scroll. So returning back to the definition, I'll just hit Control G once again, and you'll see that now we're back here browsing or navigating within the definition. And that's a really neat feature. It took me a little bit of time to get used to this, but now that I've gotten the hang of it, it's quite cool to have this kind of dynamic viewport existing within the definition. If you notice, we have a straight or diagonal rather list of points. And the important thing to note here is that this list of points is being constructed in this fashion because we have an incrementing list, which is going by X as well as Y. So as X is increasing, Y is increasing, and therefore it's resulting in this kind of diagonal list of points. To better see that in the background, I'm going to add a circle. So I'll just, again, I'm just using the search field, typing in circle. I like to use this method for things that I, kind of have a general sense of what it would take to build. The circle needs a center point, so I'll just connect that. And I'm going to use a number node again, so I'll type in number to define the radius. So let's just call this 0.5. Connect to the radius. Okay, so now we have some circles in our viewport. All right, well, if we wanted to switch the construction of these circles from a single line of points, one thing to note is that Dynamo has an algorithm for computing how the input ports construct whatever they're kind of sending into in terms of a node. So that's called a lacing operation. And here, if you right-click on the point by coordinates node, you can see that under lacing there are a few different options. Now, before I change the options here, I'm going to go ahead and take a look at another nice UI feature in Dynamo, which allows you to take a look at the data coming out of an object without using watch. So I'm just going to click this rectangle, and you'll see that I get a nice little pop-up. And this little pop-out, rather, window just shows me a little preview of what's coming out of the object. So I can see I have a list, and that list is constructed of a collection of points. And you can see here the value or the coordinates of x and y incrementing by 1, which is consistent with what we're seeing over here in our number node and also what we're seeing in our watch node here. I can collapse this list by just clicking the plus and minus. And I can also kind of click the rectangle to make that go away if I don't want to see it. Now, if you notice here on the right, we can also click the circle by center point and radius and see the output of that node updating here as well. All right, so to make changes to the lacing operation here, I'm going to right-click on the point by coordinates node. And I'm going to change its lacing functionality to cross product. Now, when I do that, you'll see that the list of data is going to convert from a line, right, that diagonal line, to now a grid. And one thing to note about this is that when that happens, we'll see that we have now a nested list of data. We can collapse the sublists here, and we can expand them by clicking the plus sign. Now, as I'm doing that, what we're going to do is just take a quick look at how that actually plays out in the background 3D preview of Dynamo. So if I select my first list, you'll see that by navigating around, Dynamo will also dynamically show what is selected with the corresponding index associated with that entity. I don't believe that it works at the kind of object level within the list, but it does allow you to kind of click through the list to get a better sense of what you're constructing in the background 3D preview. Now I can collapse that again by hitting the rectangle, and using Control-G, I'm always just kind of navigating this background, repositioning it so that I'm able to do my work within the definition, and also see a nice preview in the background. Now, we do have some circles displayed here, which looks good, but let's go ahead and see if we can't construct a surface so that we can see this in the viewport in the background 3D preview as well. Now, I type in surface, and when I do that, you'll notice that there is a collection of kind of objects that pop up. And the first one, the top result, doesn't really look like what I'm hoping to find. I'm looking for something like a planar surface, a patch, a plane, something like that. To get me a quick surface build. And when I browse down here and I see the surface category, you'll see that there are actions that you can perform, and then there are methods for creating as well. There's also query, but we're more interested in creation methods. And under create, you'll see that there is an object called by patch. Put my mouse over by patch, and I get a little rollout, and it tells me that this node will create a surface by filling in the interior of a closed boundary. So I'm just going to click on that, and I will connect the circle output to the closed curve, and very nice. So now I have some nice surfaces in the viewport, so it's a little bit easier to see what's going on. Now, if I wanted to right-click and turn the preview off of any node, you can do so by just right-clicking and selecting preview on/off. I'll do that one more time. Preview on and off. All right. Now, Zooming out just a little bit, you'll see that right now we have control kind of over just X and Y at the same time. So let's just add in a little bit more flexibility to our definition so that we can control X and Y separately. So I'll just copy and paste my number node. Zooming in over here, you can see that now I can just make modifications. I'll say 5 is for the count, and I'll connect that to Y, and we'll see that this will update dynamically. Okay, so this is just kind of on the fly, allowing us to just quickly make changes. If I wanted to have 2, for instance, in the Y, you'll see that that updates. I'll go back to 10. All right, that's looking pretty great. However, it's not that effective to be clicking in here and changing this value every time we want to see an update, to our definition. So what I'm going to do with the number node is actually replace this value with a variable. So I'm going to just call this. I'll zoom in so we can make sure everyone can see this well. I'll call this X count. All right. And when I do that, this is what's really cool about the number node, is that it will dynamically add an import to the object called X count, because that's my variable name, and allow me to then input something like a slider, right? So I'm going to do that for my other number node and call this Y count. All right, and I'm just aligning selection. I'm a little bit OCD with the kind of clean house mentality, so I'm just always kind of cleaning that up. Now we know that the X and Y coordinates for the count requires an integer. So I'm just going to type in integer, and typing that in, we'll see that the first hit is an integer slider. I'm going to hit enter and bring this little guy over here. And if you notice, here on the right side of the integer slider, there is a drop-down. And the drop-down allows you a quick access to the minimum and maximum values, specifying the range of the slider. So I'm just going to say that, I know that I need to have at least 1. Perhaps I can have up to, we'll call it 20. I'm going to close this. We'll go ahead and copy and paste it. So we have 2. And I'll take that into the X count as well as the Y count and zoom out. See if I hit run, what's going on. So we have only 1 value specified. Now I'm going to just slide this guy, walking over in X, walking over in Y. And we're back to having a grid of circles. All right, not bad. It's quite, it's pretty cool. We can see that we have this number node. We started out with, the number node doing something like this, which is a 0.10.1, right? And then we needed to define this for our X and our Y. I believe we needed to have our pound sign there. Okay, and what we've done is replace this count value with a variable so that we can have a more interactive experience by sliding the slider here and having that value update dynamically. Now, the interesting thing about using number nodes is the fact that you can use them to just input the input of an object if you need to specify a floating point, double, or an integer or whole number into the input of a node. But they also have this ability to create sequences, using these number strings, as well as introducing variables into the number node so that you can have a dynamic input created. Now, one side note, if you were to copy and paste this number node, you could, for instance, add a variable for something like start if you wanted. And you'll see that that will also update here. And we'll see that you could also say step, for instance, or increment. And it'll just keep adding these guys over here. If you notice, one thing though is that the output of the number node is really limited here, which is going to give you just one output. All right, so you can see this guy's pretty flexible. Now, the goal for today, when we talk about data and kind of data management in the pre-release 0.7, is to start to transition away from only using the kind of visual programming nodes, or using the environment as a visual programming environment, is starting to couple it with some of the features of a scripted environment. And the gateway to doing that is, well, it's been established before. You could use Python, for instance, to be able to do something in Dynamo. But one of the neat new features is the ability to use code blocks. And code blocks, if you want to just double-click on the workspace, will magically appear, and you can just start typing code in here. Right. So I'll use the code block just like a number node. So I'll say 0, ... I'll go ahead and use the X count again, ... 1. And if I want to get the output of this kind of line of code to come out, I just use a semicolon and hit enter. So the code block right now, it doesn't look that dissimilar from what we have up here. I just copy and paste my slider and bring it down. We can connect, and I'm just going to use the rectangle here to see what comes out. You can see it really, it's the same thing that we had before. Now, if I were to add another line of code, right, I could say 0, ... I'll use my pound again for white, ... 1. It's going to be my start, my count, and my increment. I'll hit enter again, and you'll see that now we have 2 outputs. And I also have 2 inputs. Right, so if I wanted to kind of riff on what we were doing before, I could just copy and paste this guy, or type in point, hit enter, and get our new point by coordinates node. And I'll just take the output of this into X and Y, right-click, and turn my lacing option to cross product. Now remember, to manage the previews, I need to right-click and turn previews off. So the geometry that I made before, I'm going to just go ahead and turn those previews off so we can just see what's being created from the code block. So these two strings of code are creating the number sequence using the ability to have this variable input generated, and then also sending out the outputs as we're typing. So if I wanted, I could zoom in here and I could say, well, let's go ahead and set Z as well. So we'll say Z equals 0, hit enter, and you'll see that this is now generated. Now if I were to come over here and I said Z equals 10 and hit enter, we'll see that this is all updating. Hit enter again and it's updating. Okay, so this is a really interesting kind of paradigm when we're talking about the visual programming environment, because it's starting to kind of blend the experience away from something which is purely node-based or purely script-based, and have a little bit more of a dynamic relationship, or a kind of a back-and-forth relationship between the two environments. Now, if we take a look at the difference between what we had here above and what we have here below, I'll just take the output of my point by coordinates node and now be referencing this guy. You'll see that in terms of efficiency, we're not really seeing a huge value return by introducing the code block. I mean, we do have 1 node instead of these 2, and I guess technically if I were to have used another number node to define my Z, say Z, you'll see that, yeah, we've kind of gotten rid of 2 of the objects and brought them all into 1. So this code block now kind of consumes or aggregates all that functionality into 1 object. But an interesting thing about using the code blocks is that you can actually use the code blocks with something which is called a replication guide. Now, when using a replication guide, which is essentially a kind of, I guess you could say it's a way of telling Dynamo how to structure data that's coming out of an object, we can actually start to build the nested data structures on the fly within the code block. So we're going to take a look at how to do that, but before we do, what we're going to do is see if we can't construct a point by coordinates directly within the code block as well. So I'm just going to double click again, and I'm going to take a look at the name of this object, which is called point by coordinates. Now, if I type in the name point dot by coordinates, we can now access the functionality of that node within the code block. So, for starters, if I just said 0, 0, 0, right? So let's see if we can't just get a point at the origin. I use my semicolon and hit enter. It's actually shift enter if you want to not have to click out of the code block. You can see that we can now take the output of the code block directly into the circle and have that update. Right, so now what we've done is removed, kind of one more node from the visual program by introducing the point by coordinates node name into the code block. As I zoom in over here, I can still use the same kind of functionality that I used before. So if I said 0, ... I'll use my pound x count ... 1. All right, we get a little error because we don't have anything coming in here. I could add another integer slider. I'm always just typing in the integer slider into the search field and connect. And we'll see that now, as I make changes here, this is going to be updating. And I'll just change my minimum and maximum value again to just be minimum of 1 and a maximum of 20, so that my integer slider will be able to kind of have a good range of values. Okay. And I'm going to repeat this process again. I will zoom in, and we'll go ahead and do this for y. So we'll say 0, ... pound y count ... 1. I hit enter, and again we're going to get an error. That's all right. Just copy and paste my slider once again and connect. And we'll see that now we have a very similar, solution as where we started. We have a point by coordinates. We have a sequence of values here that are being generated, a sequence here that are being generated, and then we have a circle by center point and radius here. If I were to change the lacing operation to cross product, we'll see that let's see if this is going to work. Let's go back to shortest, and I'm going to, yeah, it doesn't look like we can do it this way. But if we wanted to get the grid of objects to come back, we'd actually have to use this feature, which is the replication guide, to be able to nest the data in the code block. So as it comes out, it will already be structured as a grid. So when you want to use a replication guide, when you want to actually create nested data coming out of here, you have to use I'll just add a little note here. You have to use this guy right here. Okay, so we're just using a 1, a 2, right, a 3, and this is indicating the level of hierarchy that the data will be structured as coming out of the code block. So I have all of this string enclosed within these right and left parentheses, and so what I'll do is I'll just go ahead and add this replication guide for 1. And when I do that and I hit enter, you're going to see that if you do a replication guide for 1, you're just still saying that you have one level of hierarchy. You can think of that as essentially the equivalent of just having a list. List is a one-dimensional space, so we're really not adding in any kind of bells and whistles yet. But as soon as we add the second replication guide here and hit enter, we should see. Let's see if this guy is going to work for me. We should see an update, and I'm going to disconnect and see if I can't connect once again and get this guy to work. One note is that I have seen a little bit of bugginess with the use of the code block nodes. So give this a couple more tries and see if we can get it to wake up. All right, well, it looks like this guy is hung up. So what I'm going to do is I'm going to go ahead and save this file. And we're just going to go ahead and reopen it in just a second. So we'll say I'm working out of this enhanced practice folder. And like I said before, the files will all be included for you. So I'll just call this the demo. I'm going to hit save and close Dynamo. And then I'm just going to relaunch Dynamo again. Let's see if I can find that window. There we go. All right, now I'll open up that folder. Well, let's keep our fingers crossed and we'll see what happens. All right, good. So as you can see, unfortunately, Dynamo just kind of took a nap on us. But by closing it and then relaunching, we can see that the solution did correctly compute. So this replication guide for one is setting the top level hierarchy of the list, and then number two is setting the secondary hierarchy. So the easiest way to see this is by changing, let's say, the Y count to 4. I'm going to hit run again, and you'll see that now the nested list contains 4, whereas the top level list, I'll just collapse all these guys, contains 10. So here's our 10, here's our 4. Very, very cool. All right, so that is exciting. I'm quite happy with the definition as it is right now, but the power of the code block is that really what we can do is start to define a number of outputs for the code block. So if I wanted to, I could say, let's go ahead and just bring in this object interior to the code block as well. So I'm just going to disconnect this object. I will come into my code block. I know I'm going to need a radius input, and you're going to use that semicolon so that it will send the input port out as well as the output port. And then I'm going to define a variable for the points by coordinates. So I'm going to say my points equals the point by coordinates. And then at the very end, what I'll do is I'll just do the same thing I did before, and I'll say circle dot by center point radius. To define that, I just need to define my points and radius. And I use that semicolon to ensure that the output will be sent out. Right now I don't have anything defining radius, so I'm going to add in a little slider here for double. I use the search term double in here, and I'm going to limit its kind of range to be 0.5 to 2 or something, just a small amount. I'll connect that to radius. I'll go ahead and delete the circle by point, center point, and radius that I had before. We'll press run, and we'll see that now the code block is generating all of that data. I can connect the output, and if you notice here, the output here corresponds to the code line. So I'll just connect this to closed curve. I'll hit run, and we're back to having our surface patches. So awesome. So now if you notice this, the code that we had that was in the visual format, we still have this kind of visual thing going on. Our definition is still connected by wires, but now we're able to kind of bring in certain chunks of the definition directly into the code block. So to finish this out, let's see if we can't just get rid of the surface by patch. by typing in surface dot by patch. Very important to note that this is case sensitive, so you want to use the name that you see here at the top of the node. And I'll just call this my circle, so we have a little variable to use. And I'll just define my circle. Just delete this guy and hit run. All right, and now we're back to where we were. So we have 3 sliders now. I can turn on run automatically. I can change the value here. I can change the value here, right? And as I'm doing that, you'll see all of this update. Now, we're also seeing in the back, the preview of these guys in the background, so I'll delete that. Just type in 0.5 here, and you'll see everything updates, right? So the idea behind using the code block, now, I don't think it's that you want to necessarily replace an entire definition into a code block, right? Because if that were the case, maybe you would just write some code in Python, for instance. But I guess the value proposition here is that as you're starting to code in a visually oriented way, some of the messiness of that code could perhaps begin to be embedded within a code block to be able to kind of clean things up. A side note here, the code block is using the design script syntax, and because of that, you have the ability to do any kind of looping capabilities or anything you could do really in any other kind of scripting language. All right, so I'm going to just bounce back over to the PowerPoint. Let's see.